Hello and welcome to IBDP Learning Center with Mr. Tai. The following diagram represents a large wheels, the large Ferris wheel at an amusement park. The points P, Q, and R represent different positions on a seat on a wheel. The wheel has a radius of 50 meters and rotates clockwise at the rate of 1 revolution every 30 minutes. So we're given these very important information. Firstly, the radius of the wheel is 50 meters, and secondly, the 30-minute time for 1 revolution is called the period of this rotation. We can denote that by the letter t. A seat starts at the lowest point P here when its height is 1 meter above the ground. This diagram is not drawn with the proper scale because 50 meter is a lot greater than 1 meter, and therefore, there's no way that we can represent the correct ratio between 50 and 1. Anyway, keep in your mind that 1 meter is the initial height of the seat, like a cabin that you're going to get in when the wheel is at its lowest position. Question A. Find the height of the seat above the ground after 15 minutes. Okay, the point so that we can answer this question is this given time, 15 minutes. That 15 minutes is exactly 1/2 of the period, which is 30 minutes. Therefore, after 15 minutes, the point P here will rotate half a cycle to this highest point, meaning that the height of this point will be maximum, and that maximum height is calculated by adding the two radius here, 50 meter here, and then another from the center O to that top point, which is the diameter 100 meter of the Ferris wheel. And then do not forget to add the 1 meter, initial height of the point compared to the ground. And therefore, our answer for question A after 15 minutes is 100 meter. We can write 2 times of 50 and add 1, which is 101 meter. The next question B, after 6 minutes, the seat is at the point Q here. Find its height above the ground at Q. Its height above the ground is this length. From Q here, we draw a vertical straight line to the ground. We need to find this height of Q. Let's denote that by letter Q. There. So, to find the height of the point Q, we need to take the 51 meter, the distance from the center O of the Ferris wheel to the ground, and then subtract this part in the green color, which I denote by the letter delta H. Okay? Delta H is determined by using the trigonometry in the right triangle QON. This angle, let me denote this angle here by the letter theta. In that triangle OQN, we need to calculate ON, which is the adjacent side, and we know that the hypotenuse 50 meter here is, and therefore the ratio between adjacent and hypotenuse is the cosine of that angle theta there. And therefore delta H, which is adjacent here, is the hypotenuse H, which is a radius 50 meter multiplied with cosine of theta. So how do we calculate this angle theta? We know that the time for the rotation from P to Q in 6 minutes, which is 6 over 30 when we compare with the period 30 minutes. Okay, this ratio 6 over 30 is 1/5, and therefore the angle theta here is 1/5 of a complete cycle, which is 2 pi. 360 degrees, multiplied with the cosine, and 50 is our delta H, value, and we use a calculator to find that thing. Again, cosine of the angle 1/5 of 2 pi, 2 pi here. Okay, then multiply with the radius 50 meters. We get 15.45. Let's write that whole thing with the 2 decimal places. And lastly, we conclude about the height of the point Q. is 51 meter and minus this value 15.45, 55.55, and if we round it to the three significant figures, the value is 35.6 meter. This is the answer. Okay. Now the question C. The height of the seat above the ground after t minutes can be modeled by the function xt equal to 50 times sine of b multiplied with t minus c and plus 50. Find the value of b and c. The parameter b here can be called the coefficient of the period. The meaning of the parameter b here is how many times that the period of the function is reduced. Let me remind you about that property of b. Okay, here. This is a sine function x, where x is the time in this case. And of course, you have to change your calculator into radian, not degree. And if I insert a coefficient b in front of the time variable x here, b is a value that I can choose. Then if b is 1, the second function in the blue color will be exactly the same with the initial example sine x. Now if I increase this value b to the number 2 here, you see that the period of the new function will be reduced by a factor of 2. With the original function x, which is in the red color here, this point, when the function has complete one cycle, like a wave starting from the 0 and then go up to the maximum, then minimum and 0 again. This is one cycle. The value 2 pi here is the period of the sine function, okay? But for the new function with the value b to be 2, the blue function has the new period, which is pi, which is half of the period of the initial function. So the greater the b, the smaller the period of the new function. Okay, we say that the period is reduced by a factor of 2. Similarly, if I change the value b here to be the number 3, then the new period will be reduced by 3 times, taking 2 pi, the period of the original function, and divided by the factor 3 there. Okay. So the point is that you have to remember that this parameter b is determined by the formula 2 pi over the period. This t is period. And we are given in the statement of the problem, the period is 30 minutes. And therefore, we just need to take 2 pi over 30 and simplify it to be pi over 15. This is the answer for the parameter b. That's it. One of the two parameters b and c was found. Now, to find the parameter c, we need to use the information given in the initial statement here. The seat starts at the lowest point p, meaning that the initial height of the Ferris wheel, the seat here, is 1 meter above the ground when the time t in this equation, this function is 0 minute, which means x0, the time is 0 minutes, is 1 meter. And now substitute the time into this 50 multiplied with sine of b. We have found that b is pi over 15. Then the time is 0 here. Substitute the time 0 here. And then subtract the value c that we are finding. And then plus 51. And this thing equal to 1. Now, we need to solve this equation to find c. Can you see the special thing in this equation? We have the number 1 on the right side and 50 and 51 on the left side. So the only way that makes this equation possible occurs, the left side and the right side are the same thing, is that the whole thing, side of this thing is equal to minus 1. So that 50 times minus 1 plus 51. 50 times minus 1 is obviously minus 50, right? Minus 50 plus 51 is 1. Therefore, this whole thing, the sign, must be minus 1. And that can only occur, let me write that thing first. Sine of pi over 15 of 0 minus c, let's write only minus c, is equal to minus 1. And that thing can only occur when the angle inside this side, the whole thing here, the angle, is equal to minus of pi over 2. Pi over 15 times minus c is equal to that thing. The reason why I know that this angle, let's call this whole thing is the angle theta. I know that theta must be the minus pi over 2. It is two-way. Firstly, we can use a calculator. If this paper, is a paper 2, that we are allowed to use a calculator. The second way, if the calculator is not allowed, I can use a unit circle to find the solution. This is the unit circle, which is the vertical axis. This is horizontal axis. The vertical axis here is the sine axis, and for the sine to be equal to the minus 1, which is the bottom here of the unit circle, the angle which is measured from the horizontal axis here must be this angle, which is minus of pi over 2. One more thing, in the trigonometry topic in the math AA, we like always 100% use the radian, unit radian for the angle, not the degree, not degree. There. So the answer to the solution of this, equation is this angle theta equal to minus pi over 2. So c here can be found. We can simplify the minus sign both sides, and pi can be simplified also. Minus minus cancel, pi cancel with pi, and then c is 15 over 2, which is 7.5. Those things B and C are found. Let me write the conclusion one more time. B is determined by 2 pi over the period 30 minutes, which is pi over 15. This is the answer. And C is 7.5. There. This question is 5 value we see and 6 marks. Let's count the marks. Firstly, finding B with this method and correct calculation. I believe that it was 2 marks. Not only 1, you can check the mark scheme. Secondly, substitute the value 0 into here to get an equation to find the value C. This is the method mark, writing the correct equation, method mark. And we know that the sine equal to minus 1, that's the next mark, so that makes 4. 4 6 or something, but I believe that the whole solution is like this and no further step is required. The last question, D, finds the value of time when the first time the seat is 96 meters above the ground. The first time, okay, let's go back to the diagram. We need to find the first time the height is 96 meters. We know that when the point P here, the seat that we are sitting in, the cabin, goes up to here at the same level with the center, the height of this point to the ground is 51 meter. Therefore, we need a further to achieve 96. We need a further. I'm calculating the difference. 96 minus 51. This is 5. This is 4. We need a further 45 meter. Okay, 45 meter. Like the thing, the wheel P must rotate to this point. This is like the new P. To that point. So why do I know that? Because the vertical height here from P to this horizontal line, where the height is 51 here. This is the height of 51. This new height that I just drawn from the PN to this level, this red line, must be 45. Okay, 45 meter, the distance. Therefore, the angle that the object rotates is this angle here. I need to determine that angle. And to do that, I know that this angle is 90 degree. 90 degree. This one is 90 degree. So, to find the angle which is PON. I'm looking for the method to find POPN. Okay. This angle is 90 degrees, therefore I just need to find this angle first and then add 90 degrees to get the answer. You'll see later the reason why I need to find this big angle, an obtuse angle. Okay, for the small angle here, let me emphasize that thing. For this small angle, the height is 55. We use this triangle, the right triangle, to find that angle. We know this hypotenuse, the radius is 50 meter, and adjacent is, that opposite, I'm talking about this angle. The opposite here is 45. The hypotenuse is 50, and therefore the small angle here. Okay, the small angle here, let me denote that by a value, a name. Let's call this angle alpha. There. So let me use a different color to indicate that angle alpha. Alpha, side of that angle alpha is opposite 45 over hypotenuse 50 there, and therefore alpha is determined by taking the inverse side of 45 over 50. Inverse side 45 over 50 at that angle is 1.12 radian. 1.12 radian. Okay, there. And so the big angle that I want to find here, POPN, is 1.12 here plus the 90 degree, which is pi over 2. I would take this and add pi over 2, 90 degree. That is 2.69. 2.69 radian. Note that this is radian, not degree. Okay. So I want to find the time. The time taken for the first time since the start of the rotation of the wheel, so that the position of P here is 96 meters above the ground. To find that time, I'm gonna use the ratio between the time and the angle, which is like this. Okay, the solution of question D. The angle that we've just found is 2.69. Let me check that value again. Yeah, 2.69. That angle, when we compare with 2 pi, which is one rotation, this ratio will be equal to the time, the ratio between the time that we need to find for the wheel to go to that new height, 96 meters above the ground, compared to the period t, which is 30 minutes. There, we can solve this equation easily to find the time. The time will be 30 minutes multiplied with 2.69 over 2 pi. There. Do this calculation. This ratio, take this value, whole thing, divided by 2 pi. And then multiply with the period, 30 minutes. The answer is 12.4. I will round it to the 3 significant figure, 12.8. The answer is 12.8 minutes. Okay, that's it. This is about 3 marks. So we should show the method how we calculate. This is like the 2 last step. We need to find, show the method to find that angle. Again, that angle, let's denote it by omega. It's like the angular speed, so you different, this notation. Beta is 90 degrees pi over 2 plus alpha, where alpha here is the inverse side of 45 over 50. You need to write this step to get the first mark, and then equation for second mark, and result for the last mark. Okay, thank you for your time, watching the whole video. And if you have any question, please leave a comment below. I'm happy, more than happy, to help by providing the explanation right in the comment box, or you can email me in the provided email in the description of the channel. Thank you, and I hope to see you again.